Okay, we have another test here for extrema. It's called second derivative test. And that's what it could be used for. Okay. We could be using this in place of the first derivative test if it works. And what it says is that if you test your critical number in your second derivative here, and it turns out positive, then you have a relative minimum on the original function. If it turns out negative, you have a relative maximum. So I like to say, you want to test it. If f double prime is positive, concave up, relative minimum. F double prime is negative, it's concave down, relative maximum. Okay. And if it is 0, then the test fails. And you have to resort to the first derivative test if you're trying to, if that was the reason for your test. And we wouldn't be using this for any other reason. So, okay, let's look at an example here. Find all extrema, and we're going to use the second derivative test if possible. So let's jump in, find the derivative to get that started. Whoops, that wouldn't be f double prime, that would be f prime. Okay, f prime is 4x to the third minus 12x squared. Set it to 0 and find those criticals. We'll have this. So x is 0 and x is 3. Okay, well, let's find our second derivative now. That's from the first derivative, we have the 12x squared minus 24x. Now let's do our test. Let's test f double prime of 0, which is 0, so the test fails. All right, so let's check the other one. F double prime of 3. This would be 12 times 9 minus 24 times 3. And I believe that's positive. That's 72, and that's 108, so we're positive. That tells you two things. The graph is up in its concavity, and we do have a relative minimum there. Okay, concave up, relative minimum. So we're able to use that. Now, to get this other point, 0, you have to go back and use the first derivative test. So you'll have to have a 0, and we'll test around it. Make sure you don't go up to that 3. I'll test a 1 and a negative 1. Okay, so let's go ahead and test it. F prime of negative 1. Make sure you don't mix up your functions now. We're working with f prime, so it's this one here. So it looks like we have 4 times a negative 1 squared, and then a negative 1 minus 3. So it's definitely negative. So it's coming in negative. And f prime of 1 is 4 times 1 squared and 1 minus 3. So that's also negative. Okay, so 1 minus 3 and also negative. So that tells you that this is not a relative extrema. Okay, it's not a relative extremum. The graph is probably doing something like this. It's coming in negative, it zeroes out, and then it continues to go negative. So it does not give you a relative anything there. Okay. There is a horizontal tangent. There is, actually, you can see is an inflection point. We didn't test for that, but that's what's happening at that point. So we have it figured that we have a relative minimum at 3. And if we put that in, let's see, I won't even put it in. 3f of 3 is your relative minimum. Okay, and that's it. We don't have any other extrema for this graph.